Alright, hello again. This is Jeff Scott of Blackhawk Technical College coming at you right now with Chapter 8, Introduction to Table Views for the 152-153 Mobile Web Development iOS class for the spring, Swift class for the spring 2015 semester. In the previous chapter, we started to get into talking about different kinds of views, and in this chapter, as the author says here, we're going to build some hierarchical navigation-based apps. Apps of this type are typically known as master detail apps. Table views are probably the most common way of doing this. If we look on the next page here, we'll notice that they show you some examples here, and in each one of these examples, a table view is used to display the data. Now when you look at this, they don't, of course they all look a little bit different, and some of them, for instance the one here, looks like it has two columns, a column of text and a column that has images. That said, one thing about table views is they can only have a single column. There's ways that you can make them look like they're multi-column, but they can only have a single column, and they can have as many rows, really an unlimited number of rows. The only limitation is the memory of the computer. But again, they're always one column wide. Alright, now as you'll see on the next page here, a table view is the object that's used to display the table's data. It's an instance of the class UI table view. Each visible row is implemented by an instance of the UI table view cell, and that's what they're showing here. So the whole thing is the view, and each individual one here is the cell. As mentioned here, table views are not responsible for storing the table's data. They only store enough data to kind of draw themselves. All right. As they mention here, you can put more data into a cell if you need to by adding subviews to a UI table cell. You do that one of two ways, either by adding the subviews programmatically or by loading them from a storyboard or nib file. In this chapter, I believe we do the they do sort of show both of these, but it's mainly the first one, and we'll get more into the second one in the next chapter. Alright, so turning up to page 250 here, as it says, table views come in two basic styles. Whoops. Come on. There we go. There's grouped. As it says, they contain one or more sections of rows. Within each section, all rows fit closely together. It's kind of hard to see right here. I think it shows a little bit better in the book. All right. There are visible gaps, for instance, that you see right here between the A, B, C, and the D, etc. There is a little D there. It's kind of hard. It doesn't resonate well on here, but it shows up a lot lighter than what you see here. In this second example, this is the plain or the default style where the sections are closer together and each section's header can be optionally styled. Now, it's mentioned on the top of page 251 here, each table division is known as a section. All right. So what we're going to start doing here is we're going to start coming in and implementing a simple table. So I'm going to, as always, get out of here, get into Swift in just a minute, and we'll start to create that. Oh, boy. So the author says here, says, let's look at the simplest possible example of a table to get a feel for how it works. We're going to display just a simple list of text values, and it's a combination of Snow White and the Seven Dwarfs and the dwarves from the I can't even think of the name of that movie now. That's the Hobbit movies. Okay, so as mentioned a little bit later on in the page here, the author says that this is such a simple application right here that we're not going to need any outlets or actions. Alright, so let me get into here and let's just start up a new project. We're supposed to call this Simple Table, and I think it is a single view app. Normally when this spins this long like that, it's got that color wheel on it. In my case on this machine, it usually means that something's about to go wrong. So hopefully that's not going to happen. So we want to call this simple table. Alright, Swift is the language, device to universal, everything looks fine. So next. And we'll save it. First thing we're supposed to do is bring up the main storyboard. I think I've shown you this already, but since this is such a big storyboard, you know, it's so chunky and kind of clunky on the screen that quite often what we're going to do, or what I'm going to do, is click on here and go over underneath my, I believe it's the connections inspector, and change the size just to like iPhone 4-inch, just because it's so much easier to see right there. Alright. So we're supposed to look in the object library down here. We're supposed to ask for a table view. And we can see that we've got three things here. We've got a table view controller, a table view, and a table view cell. Okay, so what we're told to do is to grab the table view, bring it out here. Okay, there it is. I guess we wanted to actually have it take up the entire thing. There we go. Okay. So drop the table view into the view window and line it up so it's centered with its parents. Now let's add auto layout constraints to make sure the view is positioned and sized correctly no matter what the screen size is. Select the table in the document outline, which is what I've done, and then click the pin icon. Try that again, table view, pin icon. Oh, that's the pin icon. Alright, and when it comes up, we're supposed to set all of these to 0. These are already set. These I will have to manually set to 0. As mentioned on the bottom of page 253, this has the effect of pinning all four edges of the table view to its parent. To apply them, change the update frames right here to items of new constraints and click the add for constraints. Okay, that should now be pinned. Select the table view again in the document inspector and bring up the connections inspector. You'll notice that the first two available connections are the same as what we used for picker views, data source, and delegate. Alright. So again, we're supposed to control drag from the circle over the view controller icon in the outline to make our controller class both the data source and the delegate for the table. So, control drag. There's the first one. Control drag. There's the second one. After setting the connection, save the storyboard. As it says, we're ready to start writing code. Oops. All right. The next stop is the controller's header file. So let's bring up the single view, the view controller.swift file. So let's see if at least we can go bring it up with the assistant editor here. We'll close our navigation area over here. We don't need that. It'll give us a little bit more room, and for now We will close the document outline. Okay. A lot of this will look very familiar from what we talked about in the last chapter. Whereas previously we used UI picker view data source and UI picker view delegate, we're now using table view data source and table view delegate. Again, we'll get the error message over here because we haven't written those yet. That'll come later. On the top of page 254, we're going to add these dwarves that they want us to add. This is they're going to put them into an array. Going to put them in the same order they put them in the book. Happened, but did fix that. Okay, I believe that's everybody that's mentioned. Again, near the top of page 254. So what the author says we're doing here is we're conforming our class to the two protocols that we'll need, and we'll add that code later. And here we're declaring an array that holds the data that will be displayed in the table and an identifier for it, dwarves, which we're going to use in just a minute. Next, we're supposed to go down towards the bottom of the file and then add some more code. I'm going to open up some blank space in here. Okay. Again, I'm putting in the code that you see in your book on the middle of page 254. As you can see, I've got some mistakes here, and I'll try to clear all those up in just a minute. Okay. So here's the code that we just added. And the author mentions on the bottom of page, towards the bottom of page 254, these methods are part of the UI TableView data source protocol. The first method, the one that you see right here, is used by the table to ask how many rows are in a particular table section. The default number of sections is 1. This method is called to get the number of rows in one section that make up the list. We're just going to return the number of items in the array. The second method, as you can see, it's set up right here, so let's look, because it looks like I've got a mistake here. So func TableView, TableView, UI TableView. It doesn't look like it likes something there, so use of looks like it doesn't like this. Var cell equals TableView dot DQ reusable cell with identifier paren simple table identifier as question mark UI TableView cell. It looks like it's correct to me. So it says this method is called by the table when it needs to draw one of its rows. The second argument to the method is an NS index path instance. NS index path is a structure TableViews use to wrap the section and row indexes into a single object. To get the row index or the section index, you need to access its row property or its section property, both of which return an integer value. Still not sure what the problem is here. The first parameter here, TableView, is a reference to the table that's being constructed. This allows us to create classes that act as a data source for multiple tables. A table view only displays a few rows at a time, but it can conceivably hold hundreds, if not thousands, or more rows. Each row is represented by an instance of the UI table cell, which is a subclass of UI view, meaning that each row can contain subviews. As a table scrolls off the screen, it's placed into a queue of cells available to be reused. And if the system runs low on memory, the table gets rid of the cells in the queue. But as long as the system has some memory available, it holds onto them, kind of queues them, so to speak. So if you want to use them again, you'll be able to. Every time a table value cell rolls off the screen, there's a good chance that another one just rolled onto the screen. If the new row can reuse one of the cells that's just already rolled off the screen, the system takes advantage of this, which makes it run a little faster and a little bit better. It's kind of what we're showing in here. It's completely possible that the table view won't have any spare cells, so we check here. Now, for some reason, they show this in parens, although we should never really have to use parens here. Just was wondering if I put that in, if that would remove this, but it doesn't. Doggone. We now have a table view cell that can return for the table view to use. What we need to do is place whatever information we want into this cell, and this is a very common task. So we're going to be able to do this using the cell's text label in just a minute, but I'd like to fix that error first. Cell equals TableView DQ. Cell with identifier paren simple table identifier. I don't know. To me, it looks just like it does in the book. So to get the correct value as mentioned on the top of page 256, that's what we're doing right here. We need to know which row the table view is asking for. We get the information from the index paths row property right here. And we use the row number to get the corresponding string from the array, assign it to our cell's text label.text property, and then return it. Now it says to compile and run it, but with that error right there, I don't think it's going to compile. So let's do a file, save, did not fix that error. So I think this will fail, but we'll see. Build failed. Yeah, it's right there. As far as I know, everything that was up till there were no errors, so that should be okay. Now I'm going to try to comment this out. This is going to give me all sorts of errors later on in the program, but that's okay. Try to put it in again and see if it fixes anything. Sorry about that. Still giving me an error. Thought maybe I typed something in incorrect or put a weird character in there, but it does not like this. I don't know, sometimes if I just try doing different things like bringing that in here, which did nothing. Alright, I'm going to have to stop here. Sorry about that. And see if I can fix this, and then I'll start back up again with part 2.